representation, and then you'll have to use it. So a random variable. So it's a random value, and its value can vary. A variable can take any of a range of specific values. Sample space is all the values it can take.
Okay.
Discrete, it can only take certain values. So that's like shoe size 9, 9.5, 10, 10.5. Whereas if it is continuous, it can take any value, like 10.1 centimeters or something. Sure. Okay, these three, you have to say, is it a discrete random variable or not?
Is the first one a random variable?
Let's see. Yep.
Okay. But why? Is it because it's just, I wouldn't know how to explain it, because it's random?
It's random, and it's discrete because it can only take certain values.
Okay.
1, 2, 3, 4, 5, or 6.
And if it wasn't discrete, it would be...
Then it's not a discrete random variable.
Okay. Reaction time. Is that also random?
It's random. Is it discrete?
No.
Nope. That is continuous. And last one?
It's not random.
It's not random. It's discrete, but not random. Okay, we get the idea. We did fine. Okay, a probability distribution fully describes the probability of any outcome in the sample space. So this is a probability. These are examples of a probability distribution. So yeah, the probability distribution for a discrete random variable can be described in a number of different ways. So for example, take the random variable x equals the score when a fair dice is rolled. It can be described as a probability mass function. So the probability that x is equal to some particular value of x is a sixth, where the values that x can take are 1, 2, 3, 4, 5, 6. Using a table, this is a lot more like GCSE. X can be 1, 2, 3, 4, 5, or 6, and the probability for each is a sixth. Or using a diagram, and you'll see the likes of graphs and stuff later on.
Okay.
Maybe graphs isn't the best way. Diagram, maybe. The curves and stuff, the normal distribution curves. All of these representations show the probability takes values. These are all the same probability, a sixth, and so that's called discrete uniform distribution. Heads or tails, that's a half and a half, so that's discrete uniform distribution as well.
Okay. Just, random variables.
Yeah.
Is that what it's called? What's an example of one? So rolling a dice.
Yep. So
what's the example of one that isn't a random?
Of one that isn't what, sorry?
A random variable. I can't actually...
Number of hours in a day. That's not random. It's always 24.
Okay, but... okay.
So here you've got the height of a seedling randomly chosen. It's random, but it's continuous. The number of times a 6 is rolled when a fair dice is rolled 100 times. How about that one?
Random and discrete.
Yeah, so that's a discrete random variable. And C?
Not random and discrete variable.
Yeah. So this one up here is not discrete. This one down here is not random. And this one, the third bowl was just right. Baby bear. had the third bowl of porridge. Okay. Any idea about this one?
Just question A.
Yep.
When it says write down the name of the distribution of x, it's just same as what we were doing before.
Yeah. You may not remember it.
Um,
Has a special name.
I'm not sure now that you've underlined that.
It is discrete. It is distribution. And the important word goes in the middle. Uniform. All the same. Discrete uniform distribution.
But what does it mean?
Equal probability. So like this, a sixth, a sixth, a sixth. Or like heads and tails would be half and a half.
Okay. And is it all? Is all one word or they? Yeah. Okay.
Yeah, discrete uniform distribution. Yep.
Okay.
Right. How about this?
Write down all the possible outcomes when 3 coins are tossed. 3 heads.
Yep.
3 tails.
Mm-hmm.
Heads, tails, tails. And tails, tails, heads.
More than that. So there's also heads, heads, tails.
Yeah.
Heads, tails, heads. Tail, head, head. Tail, head, tail. Tail, head, tail. Tail, head. Tail, tail, tail. Okay. B.
But surely heads, tails, heads is the same as tails, heads, heads. Because it doesn't say that they were thrown, that they were tossed one after the other. It just says they were tossed.
This is what they mean. Right,
Okay.
they're wrongly. Okay, B. And I have a previous example here. So this is our table from before. And the other one was the mass function from before.
Okay. Yeah, no, I'm not too sure.
So table.
2 seconds, sorry.
Alright.
Yep, sorry.
Alright. So table. The random variable x is the number of heads. And so what are the possible outcomes for the number of heads?
Out
Out of all possibilities.
3 heads,
Yeah.
2 heads, 1 head, and no heads.
Yeah. So it'd be like 0, 1, 2, and 3.
Okay.
Probability of each. So
Okay.
probability.
They're all 1/6.
No. That's how many have?
Sorry, 1/8. 1/8. I think, yeah.
Yeah. Okay. How many have one head?
Same, I think.
No. So that has one heads. That has one heads.
I don't know.
3. 3 of 8.
Oh, okay.
2.
3 over 8 as well.
Yep.
And then 1 over 8.
Well done. And now write this information as a probability mass function.
So P
Yeah.
Do you have to multiply all of them? No.
So it is P.
Yeah. X equals X. How do you get the fraction?
Let me see. Maybe I need to show this first. This will be the probabilities first. So an eighth, 3/8 and 0. So for an eighth, what values of x have probability of an eighth?
Zero and 3.
And what values of x have probability of 3/8?
1 and 2.
That's it. So this thing here, I need to do something before that with this bracket thing. Okay, yes, so this one here, you see how you have 3/8 twice and 1/8 twice? Well, here they compacted it so you don't have any repetition. You have 1/8, 3/8, and so there's no repetition.
Okay.
Yeah, so you have like raw data, these like head, tail, lots of information. You simplify it, summarize it down to a table, and then you can summarize it down even further to a mass function.
Just a question. You know the 0 at the bottom. Where does that come from?
The probability of something other than 0 or 1 or 2 or 3.
Okay.
Yeah. 0 is like otherwise, yeah.
Yeah.
Okay, how about this?
And do you have to include the 0 always?
Yeah.
Okay. I'm back in page.
I'm just going to turn up my light.
So the chance of, if we draw that, yeah.
Mm-hmm.
So the chance of picking up a 2 is 2 in 4, so a half.
Hold on. All possible outcomes. A disc is drawn at random. Second disc. Number noted. Yeah. Okay. So possible outcomes.
Pick up a 2.
So 2 and
2. A 2 and a 3. A 3 and a 3.
Mm-hmm.
A 2 and a 3.
We have that.
Oh yeah, a 3 and a 2.
That's it. Okay, write it as a table.
Okay.
Let me grab
So the number of 2s. Is that x? Okay.
Yeah. X is the sum of the two numbers. Aha. So what values can x take?
4.
Yeah.
4, 5, 5, and 6.
Mm-hmm. So x can be 4 or 5 or 6. So what's the probability that x is that particular value of x?
A quarter.
Yep.
2 a half.
Yep.
A quarter.
Yep. And as a probability mass function?
It would be P x equals x
Mm-hmm.
equals, yep, 1/4, yep, x equals 4 and 6, and then a half, x equals 1 and 2. Oh no, x equals 5, sorry.
Yep.
Yep. And then 0 is other way.
Great. Great. Quarter. Yeah. 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 Okay. Let me see this one. Table. Fine. What is question C for this one?
Discrete uniform. I forgot.
Sorry?
I forgot what you were saying before.
Discrete uniform distribution. All outcomes have an equal probability.
Okay, that's, yeah, okay.
So in this case, it was a 6. All right. Yeah. The range of possible outcomes is a specific set of discrete variables where the probability of each occurring is the same. Okay. All right. So here's a table someone else made with the probabilities. Okay, let's try these. What is the probability x is less than or equal to 2?
Uh, 2 out of 6, so a third. Wow. Okay, yeah. A quarter. Wait, do all the bottom numbers add up to 1?
Yeah.
Okay. 0.63 would be.
0.63 was it?
Yeah, I think.
Yep. Let's see.
0.25 plus 6, which is 0.21, so 0.46.
No. So x has to be between 2 and 6.
Oh, okay.
What's the difference between those two signs?
One of them is equal to, and less than, and the other one is greater than.
And the other's just less than. And so how will that affect the answer?
So we're only picking 3, 4, and 5, and 2, because it's equal.
Yes.
Okay.
So it's including 2 but not including 6, and so we have to add up those. I believe we get that. So, okay, let's try A.
Five eighths.
5/8. Yeah, how about C?
Um, 7/8.
That's less than 3. This is greater than.
So x is less than 3 in this case, or greater than?
Greater than.
Okay, sorry. 0.
Yes. So it's kind of a strange one. But it's 0. 5/8 and 0. Great. Okay, how do we do top one?
The only thing I can think of is a quarter.
What did you say these would add up to?
1. Okay. So the fact that it mentions that it's a discrete random variable doesn't help.
Nope.
Okay. So 1/12.
And so k is equal to a 12th. And so how about this one down here? And you can always use calculator. Maybe you don't have 9 and 1ex. Let's see. Or you can do it long way. Plus x half. And what will they add up to?
1.
1. Shift solve. Pick your lucky number.
4.
And we get 0.25, which is the same as a quarter. Extension question. What is the probability that x is 2?
0. Oh, no. Okay. A third still?
What did we say alpha was?
Alpha?
The A?
Alpha was it was a quarter. Okay. So half plus a quarter. 3 quarters.
Yep, that's it. 3
Just
quarter.
how would you do that without the calculator?
Just manually.
Okay, yeah, I see how. Okay.
Yeah, maybe it's not too difficult with it. Let's see. Then that was that one. Let's throw that in there. Okay. It's the same idea. Yeah, it's the same idea. I think you're fine. Right, how about this?
Fine. Is it 0.7? But I don't think so. If it has to add up to 1.
It's 0.7, correct?
Okay.
B, table.
Okay. So yeah. So x is -2, -1. Yeah. 0, 1, 2. And then p x equals x.
Mm-hmm.
Zero point 0.1, 0.1.
Mm.
0.7, 0.7.
No, can't be 0.7.
I thought that's what b was, or beta.
That's what I thought. They have to add up. Aha. So I think the two of them would have to add up to 0.7. So what would each have to be?
0.35.
So actually I think our previous one must be 0.35.
Okay.
Oh, we need to watch out for that. 0.35. And then part C.
So okay, 0.1 plus 0.35, so 0.8.
So it was 0.3, 0.1, 0.1, 0.2.
Yeah, that's my bad. I calculated it wrong.
You do the math. Okay, 0.3. No. There's both of us. So that should be 0.3. It's not easy. The part A one. Like when you see it as a table, you can really see it. So maybe just writing it out as a table first is easier. Alright. Okay. How about this? Any idea about this? And if it helps, first turn it into a table.
Okay. So x is 1, 2, 3, 4. Then the chance of each one is a quarter.
It takes the value. X takes the value of the little x. So the first one is k over 1.
Okay. K over 2, k over 3. What does he mean by the number on the bottommost face is modelled?
Modelled is so a line of best fit is like a model. It's like it won't give you exactly the stuff, but it's close enough. And so in this case, it's probably a perfect model.
Okay. But when it says the bottommost face, does that mean they're taking into account the?
No, it's just like a dice or something.
Okay. So the value of k, it would have to add up to 1.
Yep.
So k, yep. Equals 1.
And with a calculator, you can easily get it. So it's 12 over 25.
How would you do it without a calculator?
Common denominator. You have
Okay.
a common denominator of 12, I think, and go from there. Yeah.
Yeah, okay.
We found k. Then give the probability as a table. And so how would we have to change our table?
Not sure.
You would now know what k is.
So put k instead of.
Yeah. And you can use your calculator. So put into your calculator 12 over, well, what is 12 over 25 divided by 1?
2, I think 2.5.
Well, I don't know, 12 over 25. Anything divided by 1 is itself. So now put into your calculator 12 over 25 divided by 2.
6 over 25.
Okay.
Then 4 over 25. And 1 over 3 over 25. So.
Okay. And then you can use that to get probabilities. Alright, 12, 6, 4, 3, 12, 6, 4, 3. Great. Alright. How about this?
Okay, so draw a table maybe. X is 1, 2, 3, 4.
You could. So what would you replace? Alright, so what would go on the bottom then?
K1. So K, 2K, 3K, 4K.
Yeah.
Okay, and then has to equal 1 anyway. And what do these equal? 10k, I think, if you add them.
Yep.
So if 10k equals 1, then k equals 1 over 10.
Well done. So k is 1 over 10. And you could do something similar for that one down there. I think you'd be alright. Is it similar? Yeah, that's similar. That's fine. Yeah, let's do this one.
Table as well? Or yeah, I think.
If you insist.
And then at the top we can put 1, 2, 3, 4, and the bottom kx.
Yep. Wait,
KX.
no. What is k? Sorry, what is x?
1. Okay, so k1. Or just k on its own.
Yeah.
K on its own for the second one as well, I think.
Yep.
3k. And 3k as well for this one. Find the value of the k. 8k equals 1. And then 1 over 8 equals k.
That's it. 1 over 8. And so if they then asked you to make the table, what would you have to change?
Substitute k for 1/8.
So that'd be an eighth. That'd be an eighth. What would be the other two?
3/8. Yeah.
I think that's our example 1 from earlier.
And for B, would it be anything lower than 1? Is that what they're asking for?
Greater than. Anything greater than 1.
Oh, Jesus. I'm getting confused with these signs. Okay. So it would just be 2, 3, 4. So 7/8. Okay.
Yeah, that one's going to be 7/8. Yep. Great. This is similar. It's a bit weird. How would you start it?
Yeah, it's a bit weird, this one, yeah.
So it's like probability x equals, so when r is 1, what is the second one?
X equals 5 minus 2.
Well, we used r as 1 first.
Okay.
So simplify.
4.
Yep. So now let's do probability x equals 2.
3.
Yep. Minus 2 equals probability x equals 3. So if we did a table, we've got 1, 2, 3, 4. What does it tell us?
That x equals 1 is 0.28.
So that was 0.28. What else can we fill in?
That 4 is 0.28 since they're equal.
That's 0.28. How do we get the other two?
add both, and then do 1 minus that result. So
Go on, give it a go.
0.44 divided by 2, 0.22.
2. 0.28, 0.22. Great. Let's see. Find the probability that total is 7 or more. We get the idea. Get the idea. Right. Yeah. How about this?
Okay. So we have to write the. I want to say options, but
Yeah. Like outcomes or something.
yeah. So, but how many? 4 spins maximum. Okay, so B, B, B.
Well, let's see. So S is the number of times the spinner is spun. So it can either be spun once, twice, 3 times, or 4 times. And so if it's spun only once, what must have happened?
It landed on red, so that's a 2 in 5 chance.
Yeah, so that one's 2 out of 5. Okay, how about spun twice?
I want to multiply 2/5 together, but I'm not sure.
That would be red and red. What must it have?
Okay, it must have been blue and then red. Okay, so 6/5.
5 times 5?
Yeah, sorry, 6 over 25.
That's it. You can always use calculator. Okay.
So okay, so 18 over 125.
18 over 125.
Yeah. And the last one, it would have to be. Well, it could just be all blue, but it could also be 3 blues and a red.
Yes. And so you could find the two separately and then add them.
Okay.
An easier way would be to do 1 minus all the other ones.
Oh.
And both will give you the same answer. And what do you get?
Minus 9 over 25.
Something's gone wrong. Shouldn't be a minus number. Let's see. So
Actually, wait, forgot to do something. 27 over 125.
sounds right. Let's see. There we go. Yep. Great. We got it. All right. How about this?
Okay, so it could be spun once,
Mm-hmm.
and that's a 4 in 7 chance. Could be spun twice, should be 4 over 7 times 3 over 7, which is 12 over 29.
49 on the bottom.
Yep, 49.
Okay.
And then the third one, it would have to be. Sorry, I'm trying to think about someone else as well. 3/7
Right?
times 3/7 times 4/7.
Mm-hmm.
36/343.
And short way of writing 3/7 times 3/7?
Not sure.
Squared.
Oh, yeah.
Next one.
It's the same, so 3/7 cubed.
Yep.
Times 4/7.
Mm-hmm.
108/2401.
Mm-hmm.
And so for the last one, just 1 minus all those results. So
Mm-hmm.
(81/2401).
And there we go. 81/2401. My extension question. Down the bottom.
So x is greater than 3, so 4 and 5, add them both together.
Mm-hmm.
To 27/343.
43. Grand. And it'll also be whatever, 189. Yeah, I'm just doing it in my head. Let's see. This is similar. That's fine. Right, tricky time. Do you remember binomial expansion? What this would be?
No.
I vaguely remember it. We want the y5 term, so it's going to be 8 choose 5. Then it's going to be 0.8y to the something, and then 0.2r. That one will be to the 5, so this one must be to the 3, so that it ends up as to the power of 8.
So what's that in the first bracket? 8c5.
Yeah, 8 choose 5. So that is, so we have 3 brackets. Let's see, so first one is 8 shift divide for choose. It's like combinations.
Oh, okay.
Second one is, I'll just put in 0.8 without the y. That's to the power of 3. Oh, that's weird. I didn't know that would happen. And then 0.2 without the r. That one's to the power of 5. Oh wow, that's weird. 8 choose 5, 0.8 to the 3, and then 0.2 to the 5. So 3 zeros, 917504. Alright. What did
So what is that related to?
I need to check. It's related to this.
Okay. I've completely forgotten binomial expansion. So, okay. I wouldn't know how to do the first one.
Let's see. So the values of n and p. X is binomially distributed. So what's the number of trials?
8 maximum.
And this time it isn't maximum. We're going to do 8 no matter what it lands on. And what is the probability of yellow?
4/5.
Yeah, so I'll write 0.8. Okay, so we do... right, what is B part 1?
I don't know.
It is, well, we want, it's like yellow 5 times and then red 3 times. So this one here was like green, sorry, like purple, green, that type of stuff.
Yeah.
So we want yellow 5 times, red 3 times.
Why do we want that?
Because they asked for probability of getting 5 yellows.
Okay.
So
Okay,
if they spin it 8 times, for it to have 5 yellows, it must have 3 reds, because now they're not stopping. They're just going to, I'll do all right.
Okay, so the second one would be 3 yellows and 5 reds.
Slow down. Okay, probability of 5 yellows, probability of 3 reds.
4/5 to the power of 5.
Yeah, I'll write it as 0.8. That's to the power of 5. And the other one?
1/5 to the power of 3.
It's power 3. However, there are many different combinations. You could have something like yellow, red, yellow, yellow, red, yellow, red. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. There you go. So you could have lots of different combinations, and the way you deal with that is you multiply by 8, choose 5. So 8 in total, combinations of 5. And so put that into your calculator. What do you get?
Sorry, just remind me what choose 5 does. What is it?
It determines how many combinations you get.
And is it always 8 choose 5?
Well, in this case, they wanted there were 5 yellows and 8 spins in total.
Okay. So the last question was that as well. That's what I was...
Yeah. And so, yeah, it's the same answer as this one. So that's 0.1468, roughly. Okay, part B.
And that decimal, what is it actually? The probability of that happening?
Probability of 5 yellows out of 8 spins. And so for that, it must be, there's like 8 combinations of 5 different yellows. So, well, if I was to put that in separately.
It just seems like very little probability of getting 5 yellows.
So there's 56 ways of having 5 yellows and 3 reds. Like one is like yellow, 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 red, red, red. Another is yellow, red, yellow, yellow, red, yellow, red, yellow. You know, there's 56 different ways of doing it. Okay. That's a roughly 15% chance. 14.7%.
Yeah.
It was close, 15%. So it's a decimal. It looks very small, but it's not too small. All right. Probability of 3 yellows.
So 3 yellows, 5 reds.
Yeah, probability.
Getting 3 yellows would be 4 over 5 to the power of 3.
Yeah.
64 over 100. Oh, you can leave it as that, yeah. Or would you like the fraction of it?
So you've got 2 more things to write down.
The red one as well?
Yeah, so this is 3 yellows.
Yeah. And so 5 reds would be 1 in 5 over to the power of 5.
Mm-hmm.
Which is, yeah.
And
then
yeah.
8 choose 3.
That's it. 8 choose 3. And then you could work that out.
Yeah.
Yeah. That's worth doing. That's that. And that's that. Aha, so we saw that earlier. And that's so that's like a 0.9% chance. That's a small one. It's roughly 0.9%. And how would we do part 3? Greater
Sorry,
than.
how did you get 0.93? Because I got 9.1.
So I'm just right. Oh, okay, so if we wrote as a decimal, it's 000. So it's 10 to the minus 3.
That's percentage.
Yeah.
Okay, I understand.
So,
Thank you.
all right. Yeah, and I'm just kind of making sense of it, 0.9%. All right, and part 3.
So x would be anything greater than or equal to 7. So is that the probability of getting 7 or less or more?
Yeah, what's the biggest you could get? Most number of yellows?
2
Highest number of yellows?
or 8, but in this case it would be
8. Highest number of yellows you can get is 8. 8 yellows, no reds.
Oh, okay, yes.
So you could do the 7 one and then add on the 8 one. There is for the cumulative, there's a quicker way. Right, we're going to do these with our calculator now. So they've summarized this down. Let's try doing it with our calculator. Although you do have to show working out for non-cumulative. So menu, distribution is 7. Wait, which calculator are you using again? Just a simple one?
Yep, still not that one though.
Alright, I'll have to go to the post office. Let me see, or tell you, 991EX, that's the one you buy.
Okay.
I think the simpler one definitely. Wait, what is your one again? What do you see when you press menu?
It's exactly the one you've just shown right now.
You see this when you press menu, is it?
Mode setup? Yeah.
Yeah. Alright. You get the idea. So there's a way that you'll need to use calculator for. That's what we'll need for next time. So yeah, you buy 991EX or graphical.
Okay.
Or I can try to post.
I don't mind buying it, but I just forget to tell my parents.
Alright. Yeah, 991EX is the cheaper one. And then the CG50 is the graphical one, and that's great. This is much better if you can get that one.
Okay.
Yeah, so big picture with this stuff is it is discrete possibilities. It's either yellow or red, and we're finding the different probabilities for each thing. We did the difficult stuff, which is the beginning of binomial distribution, which is good. Yeah, turning it into a table helps to solve stuff. Yeah, what do you give yourself for that stuff, Hugo?
Yeah, a half to a tick. It was easier than I expected from what someone told me.
It's getting there, trust me. Let's see. And so, do you want to continue this next time or something else?
Yeah, definitely. Yeah, this is a good. Yeah.
Any questions for me in general?
Yeah. So you say we've done the hardest of chapter 6.
We did the kind of see. Nah, the worded questions. So you then have to just turn it into worded questions.
Okay.
But we've done it properly. So when you there's a thing to put this into your calculator, where you just put in this previous one. You'll put in 8. You'll put in 4/5, and you'll put in 5, and it'll give you the answer 0.1468. But later on, you'll have to actually read a worded question and say, well, what is n? Here, like n would be 20, p would be 0.15, and x is 7. And so you have to actually figure out what the 3 values are to put into the calculator,
Okay.
and kind of make sense of it. That's a bit. It's harder when you get the worded questions. Anything else?
Yeah, just the volume on the last video. There was a problem with it. Do you think this one will be alright?
Hope so.
Okay.
Was there no audio?
Yeah, exactly.
Yeah, I think I fixed it, but maybe we could use Zoom if you want. Zoom has like a backup, but yeah, I think I fixed the audio.
Okay, that's great.
But I don't have a backup for doing, like some students do on Zoom, and for them I was able to change it to the one that had it, but unfortunately you and I think one other student, there was just no audio.
I think I can do it on Zoom. Do I just have to download the Zoom app?
Yeah.
Okay. Yeah, it should be alright.
All right. Anything else?
No, it's great. Thank you.
All right. Well done, Hugo. You did great, and I look forward to chatting again next week.
Great, thank you. See you next week.
Have a good one.